Welcome back to the channel, and in this video we are continuing with the review of the F407 power harmonics clamp meter from Chauvin Arnoux. We finished the previous video looking at some power measurements, so we picked that up here. And we can add to this with a long press of the yellow button here. We have single phase and three phase. I only have a single phase test set, so that's all we can measure. However, with the Hertz harmonic button here, in power or watts mode, a long press of this will take us into energy analysis, and we have to turn this on or off with the yellow button here. So we are off, turn it on with that, you can stop, turn it back off. If we turn it on, we've then got a number of screens that we can page through to show that this is working. This is the normal time screen, so this is telling you how long it's been on for and what it's been paging in seconds, minutes and hours. Then keep going through that, and then we'll go into the watt hours there for the load, and we can page through these. Some of them reactive power won't obviously have anything because I didn't put anything on that. We're just reading watts, and then we can go through. We'll get on the VA there, and then on to supply. So these settings here seem to be similar to the CA8220 that we looked at a little while back. Same format, so which is nice to see some consistency across instruments really, and that's all you have with the power functionality. So what I will do now is move into doing some measurements in comparison to the calibration cert that I got and see how well my figures compare to their certificate. With it being a current clamp meter, we may as well kick off the calibration measurements in measuring some current. On our test certificate on the 100 amp range DC, where they were injecting 50 amps, they've got 49.86, I've got 49.52. They also did this in AC/DC mode as well, which we get through our yellow button. It's through AC/DC mode. They were 49.87, pretty much the same, on 49.52, pretty much the same as well. So they did some measurements in between. I'm going to ignore those because the accuracy is pretty good on this. I'm just going to take it straight to their highest reading, which was 1400 amps, which I need to inject 28 amps on a 50 amp clamp. And we need to be in DC mode, and we've got 1403. AC/DC mode, it can only measure up to 1000 amps, that's why it went over range. So they had smack on 1400 there. I've got 3 more amps on my setup, which is totally acceptable. So the bottom end measurement, they did 45 amps on AC current, so we can switch that on. We are, that's DC, so we are 44.91, which matches theirs, 44.91. So smack on with the AC. And they did some other measurements as well, but the ones I found interesting is that they moved to 1 kilohertz, 50 amps, and they got 50.47. So I'll just change this to, there's 50 amps at 50 hertz. You can see we're 49.92, which is all good. Take up to 500 hertz. Which there's 51.63 now. If I go to 1000, you can see I've popped up to 56ish, and they had 50.47, so I'm struggling with matching the certificate on that one. I think it's something to do with the test setup I've got going on here, so I'll put some other test equipment together and see if I can get a closer reading than that. When we're at, what did they do, 500 hertz, they did 120 amps, so we go back to 500 hertz, we know everything's reading okay. When we are in either our current or our voltage mode, we can just short press and we can go straight into the frequency, which comes on the middle line here, which is 1999, so it's picking the frequency up okay. Just doesn't like the voltage value. So we'll have to do some more experiments and see where we are with that. We can drop it to 500 as well, just to show that. 500, our value seems to be in spec at 500, and we are reading 499.9 Hertz, and then back down to 50 as well. We are 49.9, 50 Hertz. So frequency wise seems to be all good. It's just that one current measurement there on AC that I appear to be struggling with. What I've just done is put an ammeter in series with the clamp table here, so we are at 500 Hertz, 1 amp going in, we're reading 51 amps on clamp meter there, which is good and in spec. I'll just take it to the 1 kilohertz and just see what happens. So we are kicking out 1.1 amps from our test set, which is obviously giving us our 55 amps, isn't it? So it appears to be something wrong with the SMRT1 there. Let's go 0.9. 0.91 we've got coming out, so we are on 1.005 amps going in, and we've got 50.75 amps going in there, which should be within specification. So it's something to do with the SMRT1, and its output there is not quite right at 1 kilohertz, but if I tweak and verify it with another instrument, it looks like we're all good. Whilst we have our test set out as well, we'll switch it back to power, and we'll look at, so they had some weird and wonderful power values on their test certificate, which I can generate, I can get close to them. What's the issue that I'm having really is that I don't know whether they switch the instrument into a specific mode when they do their calibrations. Being the manufacturer, they probably have more information, don't they? But I can't get the resolution that they get here, even our 150 watts. There's our 150 watts. They had 148.6, but I can only get to 149, so it's the same value, because you would round up on 148.6, but I can't seem to get that extra digit throughout this kilowatts range, which is rather strange. Again, we go to 27101 kilowatts, so let me set that up. So on our 27 kilowatt setting, they got 26849 watts, displaying it as watts. You see here I'm displaying it as 27, virtually 27 kilowatts. So it's within spec, but I'm not getting the resolution that they're getting during their tests. So don't know quite what they did to the instrument. Nothing in the instructions to say you can turn this to a manual range. So I presume it's something that they are doing. So what we will do is kick this out of the way, and we'll set it with a piece of different test apparatus to see if I can resolve the 50 amps at 1 kilohertz, and we'll also look at some voltage measurements as well, because that kit has got a higher voltage measurement capability. So we are set up to read DC voltage. I won't go through all the settings. We are currently injecting 900 volts, and we've got 899.9 down at the bottom here on DC volts. We can go down to 90 volts there, and we're reading 89.9990. 9 volts it had, 0.96, and then 0.9 volts. We are on 0.88. They did plus minus on that as well, and then we are 0.89 on that one, so that all looks to be good on the DC. Pretty good matches there. Now flick over to AC volts. Let's do AC/DC. AC/DC, they have some weird and wonderful values on AC/DC. They started out at 0.64, and we had 0.63 for the results, which we've got matching exactly. They then went to 6.36. Don't ask me how they got these, this is weird. 6.34 I've got on the instrument, and that matches cert. The next one was in 35.36. which we are 35.30, they got 35.32, and then finally 141.2, which they got 141.2 is what they got. They should have been injecting 141.4, which I need to check that, don't I? So that's 141.4, and we are 141.1 on my measurements here. So that's all good with that one. Let's knock him off. They also did a peak measurement as well. They put in 28.28 peak measurements. Switching on there, we need to be on AC, and we've got 19.96 volts there. If we hit the peak button, there we go, our peak plus and our peak minus, 28.31 and minus 28.32, which they got 28.31 and minus 28.33, so that all looks to be good and accurate. So for AC voltage measurements, they started out at 0.5 volts, which you see we've got here 0.49, which matches their cert, times 10, or 5 volts, 4.98, which matches 50 volts, 49.94 we got 49.93, that's all good. They then went to good old 230 volts. And we've got 229.5 on that measurement there. We'll pop them all the way up to 900 as well. 898.6 against, they got 899 there. They don't show the decimal place on that one for some strange reason, not sure why. Okay, they then moved to a load of frequency measurements, which they all did at 20 volts. So to get to frequency, we are 50 hertz there, there's our frequency in the middle. We're 19.95 volts, which against 20, which they did get 19.98, so that's all good. They then went up to 500 hertz, and they had 20 volts, we've got 19.98, but we've got our 500 exactly. They then went to 3 kilohertz, which is that one there. We've got our straight 3 kilohertz, 20.77, they had 20.82. They then went to 15 kilohertz, which is outside the scope of my calibrator. I can only go up to 10 kilohertz with this calibrator, which we show you there, 10 kilohertz. But we have lost our voltage off. Intriguingly enough, we're no longer picking up 20 volts. Interesting, I don't know why that is. They don't show a voltage measurement at 15 kilohertz, so that's probably beyond the spec of the instrument. To get to 15 kilohertz on sine wave, I would need to put a signal generator into circuit. As I said, this calibrator can't actually do that. But that's all those voltage measurements there, all pretty good, no major problems. What I'll do, I will stick up I'll get a frequency generator out, and we'll go for 15 kilohertz and see how close we can get, and then we're just on to resistance measurements after that. We've set up with our function generator. We're currently kicking out 1 volt RMS at 15 kilohertz. You can see we haven't actually got a display at this moment in time. If I pop them up to 2 volts, then you see we do kick them in with 15 kilohertz there, but still no voltage being displayed. I'm not sure if it does 3 volts, 4 volts. No, 3 volts is the highest my function generator will go on volts RMS. So that seems as high as we can go with this particular function generator. I don't know if you take it higher you will get volts RMS, or at 15 kilohertz you just get a frequency reading, and that's all you get. I'll have to look through the manual, see if it does spec that somewhere, but 15.00 does match the data on their calibration certificate, so that's all good as well. We'll move on to some resistance measurements. Onto our resistance test function. Using the dial here, you can flip between resistance mode and continuity mode there. continuity mode. So buzzing is coming in at around about 40 ohms by the looks of it there. Yeah, 39. Going off at 44 there. So that's your continuity. Resistance wise, zero everything. There is no zeroing function for the resistance. So our leads here plus the resistance of this box, which is around about 70 milliohms, is giving me 0.1 of an ohm at this moment in time. A straight 10 ohm resistance is 10.1. They have 10.08 on their sheet, so again we've got this issue where they seem to be able to get more resolution when they do their tests. It also appears at the other end of the scale as well. Let's go halfway. We are 800 there, 799.2, they are 800, and 2000 ohms. So 2000 ohms, we are smack on 2000 ohms. We go up to 5000 there, 4999, and all the way around we go to our 20 kilo ohms. So you can see when we go into our 20 kilo ohms, they're saying they got 20.026 ohms, whereas for my instrument it's flipping over into a kilo ohms range there, and I've got 19.92. Still within spec, it's just not getting the resolution that they are, and the same goes for that all the way up to there's our 50 there is 49.8, and our 90 was the last one they did, which was 90011 for them, and I am 89.61. So that's our resistance function there, again all within specification. So that's the review of the F407 power harmonics clamp meter from Chauvin Arnoux. You'll have seen the results, the test results come up as I've gone through the individual tests. We'll just put up this summary table now, which is the average of all the individual tests that I've done in categories, and then an overall average. Overall you can see that the Chauvin Arnoux readings gave me 0.35% out of tolerance reading. My readings were 0.42%. So very, very close to the readings that they got. I'm more than happy with all of them. Just goes to show how accurate this equipment is from Chauvin Arnoux and its consistency in operation. We haven't looked at a couple of the items. I haven't looked. This does have harmonics on it, obviously. With it being a harmonics meter, I can't get the harmonics to work on my test set for some strange reason, so I'll have to try and figure out another way of working with that. And we do have the software as well. This is a Bluetooth enabled meter, and the software, once I've figured out where I need to download it from the Chauvin Arnoux website, I'll get that installed on the laptop and then we can look at that. But to be honest, for me, I probably wouldn't use the software that much with this meter, but that's personal preference, of course. The only real negative with this meter for me is when you're on DC, with them putting the DC reading down at the bottom here, it changes the angle really of how you look at it. Obviously you can see it all okay there. If you're a little bit tilted, then you miss a few of the very bottom of the digits off, if you like. You can miss the position of the decimal point. Just makes it a bit awkward to read, but other than that I don't really have any issues with the meter. It obviously is a big meter. It's a 1000 amp clamp, isn't it? So it's going to be a little bit chunky in comparison to a lot of the others on the market. They do the 200 series below this, I believe it is. I think they have one that's equivalent to this, so that may be more suitable to people. I presume it operates in exactly the same manner as this one does. So overall, very happy with the clamp. Should be a nice instrument to use. So in terms of other clamp meters to look at, I'm probably only missing one from Fluke really. I should get a Fluke clamp meter and see how it compares to these other ones that I've got. But that'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.